In this video, you will learn about a significant category of surfaces known as quadric surfaces. These surfaces are similar to the conic sections, ellipse, parabola, hyperbola, in three dimensions. Hence, it can be said that a quadric surface is merely a three-dimensional version of a conic section. Please don't forget to click on the like button, subscribe to our channel and activate the notification bell. Your support is crucial for our channel's growth and enables us to continue creating quality content. Thank you in advance for your support. The four main classes of quadric surfaces are cylinders, ellipsoids, paraboloids, and hyperboloids. Some cylindrical surfaces are quadrics and some are not. That's why I made a video just about cylindrical surfaces before this one. In this video, we will cover ellipsoids, paraboloids, and hyperboloids. The fourth basic type of surface in space is a quadric surface. Quadric surfaces are the counterparts in three dimensions of conic sections. Let's start by defining a quadric surface. A quadric surface is the graph of a quadric equation in three variables, x, y, and z. The most general such equation is for constants a through j. When the coordinate x's are chosen to coincide with the axis of the quadric is then said to be in standard position. In standard position, the coefficients d, e, f are all zero, and the linear part also reduces to just one term. In standard position, the equation of the quadric has a simple form, and in this video, we restrict our attention to quadrics in standard position. In order to sketch the graph of a quadric surface, it is useful to determine the curves of intersection of the surface with planes parallel to the coordinate planes. These curves are called traces, or cross-sections of the surface. When a quadric surface intersects a coordinate plane, the trace is a conic section. Like conic sections, quadric surfaces are classified into a small number of types. There are six basic types of quadric surfaces: ellipsoid, one-sheet hyperboloid, two-sheet hyperboloid, elliptic cone, elliptic paraboloid, and hyperbolic paraboloid. Let's start with the simplest equation. In standard form, an ellipsoid has the equation for A equals B equals C equals R. This equation is equivalent to the equation for the sphere of radius r. A sphere is a simple quadric surface. The following example illustrates how you can sketch the graph of an ellipsoid. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, begin by writing the surface in standard form. Begin by writing the original equation and then divide both sides by 9. Now you determine the traces in the coordinate planes. To find the xy trace, you set z equals 0. To find the xz trace, you set y equals 0. To find the yz trace, you set x equals 0. Finally, you obtain the intercepts with the coordinate axis, and then sketch the elliptical traces in the coordinate planes. The surface analogues of parabolas are elliptic paraboloid and hyperbolic paraboloid. In standard form, an elliptic paraboloid has the equation If y equals 0, then xz trace is a parabola in the xz plane. If x equals 0, then yz trace is a parabola in the yz plane. If z equals 0, then xy trace is one point in the xy plane. If z equals 1, then xy trace is an ellipse in the xy plane. The variable raised to the first power indicates the axis of the paraboloid. The following example illustrates how you can sketch the graph of an elliptic paraboloid. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, start by writing the surface in standard form. As we can see, x is raised only to the first power. The surface is a paraboloid, and the axis of the paraboloid is the x-axis. We obtain this equation in standard form by isolating the variable x. We now find the traces of the figure and sketch the surface. If y equals 0, then xz trace is a parabola in the xz plane. If z equals 0, then xy trace is a parabola in the xy plane. If x equals 0, then zy trace is one point in the yz plane. If x equals 4, then yz trace is an ellipse in the yz plane. The next quadric that will be presented is the elliptic cone, whose equation is given below. In standard form, an elliptic cone has the equation: if z equals plus or minus c, then xy traces are ellipses. If x equals 0, then yz trace are pairs of lines in the yz plane. If y equals 0, then xz trace are pairs of lines in the xz plane. A rough sketch of the elliptic cone can be obtained by first sketching the elliptical traces in the planes z equals plus or minus c, and then sketching the linear traces that connect the endpoints of the axis of the ellipses. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, start by writing the surface in standard position. We obtain the equation of an elliptic cone in standard position by isolating the variable z. A rough sketch of the elliptic cone can be obtained by first sketching the elliptical traces in the planes z equals plus or minus 1, and then sketching the linear traces that connect the endpoints of the axis of the ellipses. The next quadric that will be presented is the hyperbolic paraboloid, whose equation is given below. In standard position, a hyperbolic paraboloid has the equation: if y equals 0, then xz trace is a parabola in the xz plane. If x equals 0, then yz trace is a parabola in the yz plane. If z equals 0, then xy trace is one point in the xy plane. If z equals 1, then xy trace is a hyperbola that opens along a line parallel to the y-axis. If z equals minus 1, then xy trace is a hyperbola that opens along a line parallel to the x-axis. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, start by writing the surface in standard position. As we can see, y is raised only to the first power. We obtain this equation in standard position by isolating the variable y. A rough sketch of the hyperbolic paraboloid can be obtained by first sketching the two parabolic traces that pass through the origin, one in the plane x equals 0 and the other in the plane z equals 0. After the parabolic traces are drawn, sketch the hyperbolic traces in the planes y equals plus or minus 1, and then fill in any missing edges. The next quadrics that will be presented are the hyperboloids, which come in two types, depending on whether the surface has one or two components. We refer to these types as hyperboloids of one or two sheets. In standard position, a hyperboloid of one sheet has the equation: if z equals 0, then xy trace is an ellipse. If z equals plus or minus c, then xy traces are ellipses. If x equals 0, then yz trace is a hyperbola in the yz plane. If y equals 0, then xz trace is a hyperbola in the xz plane. The axis of symmetry corresponds to the variable whose coefficient is negative. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, start by writing the surface in standard position. The axis of symmetry is the x-axis. If x equals 0, then zy trace is an ellipse. If x equals plus or minus 1, then zy traces are ellipses. If y equals 0, then xz trace is a hyperbola in the xz plane. If z equals 0, then xy trace is a hyperbola in the xy plane. In standard position, a hyperboloid of two sheets has the equation. Let's rewrite this equation as follows, as we must analyze it carefully to understand the construction of this surface. The right-hand side of the equation is always greater than or equal to 0. Thus, there are no solutions with absolute value of z less than c, because the left-hand side is negative. Therefore, the hyperboloid has two sheets, corresponding to z greater than or equal to c and z less than or equal to minus c. The axis of the hyperboloid corresponds to the variable whose coefficient is positive. If z equals 0, then there is no xy trace. If z equals plus or minus c times square root of 2, then xy trace are ellipses. If x equals 0, then zy trace is a hyperbola. If y equals 0, then xz trace is a hyperbola. Sketch the quadric surface with the equation. To classify and sketch a quadric surface, start by writing the surface in standard position. The axis of symmetry is the y-axis. If y equals 0, then there is no xz trace. If y equals plus or minus 2 times square root of 2, then xz trace are ellipses. If x equals 0, then zy trace is a hyperbola. If z equals 0, then xy trace is a hyperbola.